Okay, so for question number 1 here, we need the formula for dinitrogen trioxide. First off, is that ionic or molecular? It's molecular, that's why it's got prefixes in it. Okay, so there are 2 nitrogens and there are 3 oxygens. So they need to have N2O3. Okay, they got that, they get the mark. All right, for number 2, we got calcium and chlorine together. Is that ionic or molecular? It's ionic. So we got to do our swaps and drops here. Calcium is a 2+ charge and chlorine is a -1 charge. So the 2 goes here, the 1 goes there, but we don't write 1s. Okay, and we're left with CaCl2. It must look like that for them to get the mark. There are no half marks. Okay, I don't believe in half marks. You either did it right or not. You can if you want, yeah. Okay, so CaCl2 is our correct answer for that. For number 3, I've got copper, Roman numeral 2, nitride. Is that ionic or molecular? Ionic. All right, what does the Roman numeral tell me? The charge to use when I do the swap and drop. Okay, nitride is N, and that's -3. Right, so I take the 2, I drop it and swap it, it goes here. I take the 3, I drop it and swap it, it goes here. Okay, so our formula ends up being Cu3N2. And then for number 4, I've got magnesium sulfate. Ionic or molecular? Ionic. Magnesium is a metal. Okay, so Mg, that's a 2+. Sulfate is a -2. So is that already balanced? All right, so that's our formula then. MgSO4. Questions on the first 4? Okay. For the second 4, we've got to write the actual names for these. Okay, so I've got sulfur with bromine. Ionic or molecular? Molecular, all right. So I don't put mono on the first one, so that's just going to be sulfur. And then what prefix do I need on bromine? Tribromide. Okay, since I did mention before the quiz that chemical names don't start with capital letters, they can't have capital letters. If they do, it's wrong. Okay? All right. Number 6. I've got lithium with oxygen, which is an ionic compound. Now, does lithium have more than one possible charge or just one? Just one, and it is one. Okay? So we just have here lithium oxide. Number 7, I've got iron with nitrogen. Okay, ionic or molecular? Ionic. Does iron have more than one possible charge? So this one's going to need Roman numerals. Okay, figure out which Roman numeral I'm going to need. First, I'll write out the things that are going to be there. Iron nitride. Okay, nitrogen's a -3. And there's only one of them. And there's only one iron, so iron has to be +3. So iron, Roman numeral 3, nitride. Okay, and the last one, I've got sodium with nitrates. Okay, ionic or molecular? Ionic, because nitrate is a polyatomic ion, and this is a metal. So sodium nitrate. That's an M. Sodium nitrates. All right, give them a mark out of 8. Write it at the top. Let them see it, and then I want them in a neat pile right here. Okay, so yesterday we had just finished talking about your procedure, okay, and what a procedure is. Okay, most of the time you will not write the procedure. Most of the time I will have written the procedure, and it'll be an explicit set of steps for you to follow. Okay, where everything is really laid out for you. Provided you read the procedure, you basically shouldn't be able to screw it up. Okay, that's how detailed a procedure has to be. Okay, now this first lab you will be writing the procedure for it. We'll be starting the work on that tomorrow. okay, where you're going to need to tell the person, okay, me, who's going to be reading yours, what steps to follow. And also for yourself, because when we go across to the lab, all you're going to have is your procedure to follow, right? So you need to tell yourself, all right, first I got to go and acquire the materials. I got to put them in the depression plate, okay? I've got to put this much in the depression plate. You got to indicate all of that kind of stuff. Otherwise, maybe you'll pile it on there. I don't know, okay? But you got to make sure that you've got the right amount, okay? What kinds of things are you going to look for in the observable properties test? How will you know? What kind of things should you record? Same for the conductivity test, right? If all you write for the conductivity test is stick tester in pit, okay? Press button, I'm going to go, yeah, that's not really helpful, because some idiot will go, right? You have to assume the person reading that your procedure is a complete moron, okay? And then if you don't tell them everything, they'll screw it up, okay? It really has to be like boiled right down to the easiest possible way to do it, all right? Now, the other things you sometimes need to include in a procedure is instructions on how to maintain your controlled variables, okay? We talked about the controlled variables are those things that need to stay the same throughout an experiment so that they don't have an effect on the lab. A lot of times in the procedure, you're explaining to people how you set up the lab so that the controlled variables do in fact remain controlled, okay? The example we had was the plants, okay, and that they were going to get different amounts of light, but we said temperature needs to be the same. Right? So we have to make sure they're in, a room where the lights themselves are not going to alter the temperature for the growing area for any one particular plant. We said they all had to have the same soil, okay? Those kind of things. We can say that in the controlled variable, but in the procedure, we've got to outline how are you doing that. I'm going to the store and I'm buying 2 bags of potting soil, same brand, okay? And I'm filling up the pots this much for each pot so that they all get the same amount and the same kind of soil, right? That would be in your procedure. How am I setting this lab up, right? Other thing that would be in your procedure for our plant example, every other day, the plants will be watered with 100 milliliters of distilled water, right? Be specific. Don't say, give them a little drink, all right? Because, then some idiot will come along, he'll take a rock star, crack it, and start feeding it to the plants, okay? Which is going to kill them, obviously, right? Plants don't like caffeine so much. So, right, we gotta be mindful of how we're instructing somebody to do the lab. I know it seems like that's kind of obvious, and it should be, but you got to remember, common sense is not common, okay? You assume it is, but you're wrong, okay? You guys haven't maybe seen this as much, but when you get old like me, okay, you'll see that common sense is common to about 25% of the population on a good day. Okay? Yeah, right? So you can't assume that someone's going to just know what you knew. All right, after the procedure, okay, or during the procedure, you're going to acquire all of your data, observations, and things like that. Okay? So you're going to have a section underneath the procedure that will be for all of your observations. Sometimes that's going to be a chart. For this first lab, a chart would be a good way to record the data for each unknown compound that you're going to be testing. Okay? Sometimes your graphs will go in there. Okay? If it's not a graph that's actually analyzing something, if it's just a graph of data, okay, then you can put it in there. Okay? Sometimes we show calculations in there. Sometimes calculations go in the analysis. Okay? Either one at this point is fine. Okay? And anecdotal observations. Okay? What's an anecdote? Anybody remember from English? It's kind of a story, okay? Well, anecdotal observations are ones where you're writing down qualitative stuff that you've observed about the plants, okay? Or in this case, the plants. So it could be something like, on the second week of the experiment, plants with less than 4 hours of sunshine were starting to look noticeably pale by comparison to other plants. That's a qualitative observation. It's not any less valid than measuring how tall they are, okay? It's an observation that you've made, okay, that could be important later. Why would they be pale? Well, because they're not getting very much sunlight, right? Okay? You might also notice that plants getting more than 20 hours of sunlight are starting to look wilted. Right? You could write that as an anecdotal or qualitative observation. It's still valid. It's something you've noticed. Okay? You haven't said why. You've just said, this is what I'm seeing. Okay? The why part, that's your analysis. Okay? That comes in the analysis part of an experiment. Okay? It was noted that plants receiving more than 20 hours of sunlight looked wilted. This could be because they're losing more water to evaporation because of the intense sunlight they are receiving. That goes in the analysis part. That's you drawing a conclusion, okay, or making or generating an idea as to why. The observations don't say stuff like that. The observations just say what you see. Everybody follow me there? All right, so don't try and analyze anything in the observations. Just write down what you see or measure. Okay, and then in analysis, most of the time for you guys, there'll be analysis questions that you'll have to answer, okay, or there'll be calculations that you'll be asked to perform. Okay, so that's what would go in there. That's taking the observations and doing something with them, right? That's what the analysis is all about. Okay, if it's asking you to explain something, then you need to have a detailed answer. Right? So if in your analysis for this plant lab, okay, one of the analysis questions was, explain any patterns that you noticed between the plants. And you write down, some grew well. That's not really an analysis, okay? That's a poor restatement of your observations, all right? A better answer to that would be, it seems clear that there is a range of times or exposures to sunlight that allow plants to perform well, okay? This range seems to be between 6 and 18 hours worth of sunshine, okay, or worth of light, or whatever you gave them, okay? Plants within this range seem to do well, with plants doing best between, let's say, 8 and 14 hours, all right? You might even want to narrow the range, or maybe ones between 10 and 14 hours did the best, okay? Because most plants, in reality, they get about half a day worth of light and half a day worth of dark. That's how they've evolved. That's how they are adapted to live, right? So that would be explaining something, okay? It's not just a restatement of your observations. You've done that too, but you've also said that could be because plants do need some time where they're not exposed to sunshine in order to do other things related to photosynthesis, right? Now you're analyzing. Now you're taking your observations and going somewhere with them. You guys follow me there? Okay? So sometimes you have to say quite a bit in the analysis. Very rarely is an analysis question yes or no. Okay? It's got to be more than that. Yes, because. No, here's why. Right? You got to have some explanation in there for that. Right? Once you've made your analysis, then it's time to come up with a conclusion. So in your conclusion, you need to do two things. You need to restate your hypothesis. Okay? You need to tell people, remember, this is where I started. Okay? This is what I said at the beginning. Okay? So you restate that. For you guys, that's easy. Copy and paste it from the beginning of the lab. Right? Don't bother rewriting it in a different way. Okay? You already went through the effort of writing the hypothesis once. Just copy and paste it back down. Okay? And then explain, using your observations and analysis, why you can accept it or why you have to reject it. Okay? Yeah, you can say it's plausible, okay? Or you can say I can conditionally accept my hypothesis, or something along those lines. Okay. So a conclusion is going to be a short paragraph. Okay? Because you're not just, you're restating your hypothesis. That's probably going to be a couple of lines to begin with. Okay? And then underneath that, it's going to be something like, I have to reject my hypothesis about the plants getting the most sunshine will grow the best, because that is not true. The observations clearly show that plants receiving more than 20 hours of sunlight did not perform well, ended up losing more water to evaporation, drying out, and dying, okay, over the course of a month. Okay? It does seem, however, that there is a range of sunshine between these hours that seems to be most effective for growing plants, while plants receiving very little sunshine seem to do very poorly or die completely. Okay? That would be an explanation. That's your conclusion. Your hypothesis wasn't right. These are the observations you saw that say it wasn't right. And here's something you learned during the experiment. There is a range of exposure to sunlight that seems to be best for plants. All right, everybody follow me there. All right. But I so often see this instead. My hypothesis was right. Period. Why? How do you know? Okay, just saying my hypothesis was right is like going na boo boo. I was right. Okay, you can't just end a lab that way, right? You have to say why was it good? Okay, why did you accept it? Hypotheses are rarely completely right. Okay, I accept my hypothesis on these grounds. Okay, I reject my hypothesis on these grounds. There has to be an explanation as to why. All right, and if the explanation is because the results say so, is also not good enough. Okay, what did the results say exactly? Okay? You have to tell people that this is the conclusion I'm drawing based on the data and my analysis of it. It could be wrong, but that's the conclusion I'm drawing. Okay, and it's got to make sense with what you said in the hypothesis and make sense with what you got for data or observations in the lab. Everybody follow me there? Okay. All right. The last part of your lab is your evaluation. Okay. In that, okay, you essentially evaluate the lab. Was it effective? Okay. Did it get you the data you needed? Right. Usually here we identify 2 sources of error and we suggest ways to fix them or eliminate them for the next time. Okay, so in this lab with the plants, I might have noticed that by the end of a month, the soil was starting to get kind of packed, and plants were having a tougher time growing roots in general. Okay, so the next time I could say, maybe I would try this experiment with 2 earthworms in each pot, because they might turn the soil over a little bit for me. Okay, keep it from getting too packed. Okay, or maybe I noticed that plants don't normally get distilled water in nature. I watered with distilled water. Next time I might water with water from the tap or water that has plant food mixed in with it, or something like that. As long as every plant gets it, you're okay. Okay? But it would maybe help the plants to grow. If you notice all the plants generally struggled, then maybe that's a source of error. Okay? Yes, these plants still did better, but all the plants in general didn't grow very well. A source of error then is something you did in the lab. Distilled water is not great for watering plants with. Okay? So maybe we would try something else the next time. Everybody follow there? So little things. But here's the thing people do all the time, and you should never do this in a lab report. Yeah, I screwed up step 5, and so my results aren't very good. That's a source of error. No, that's a correctable error. Go back and fix it. Do it right. Never say after an entire experiment where you've already arrived at a conclusion, oh yeah, I screwed up somewhere along the way. Okay? I didn't do this right. Because now the person's going, thanks for wasting my time. I just read your whole lab report, and now you basically told me the whole thing is invalid because you screwed it up. Okay? You never list human error as a source of error in your sources of error. Okay? Because you can fix that. All right? If you recognize you've done something wrong, do it again. But don't do it wrong again. Do it right. Yeah. Okay? You guys follow me there? Correct your error. Okay? If it's a correctable error, correct it. Don't finish the lab and then say you did it wrong. Okay? Because then the whole thing is invalid. Right? And in fact, even though I tell people this, I still have people write that. Yeah, we had trouble measuring step 4. So why didn't you do step 4 again? I just look on there and go, yeah, 0, okay, for sources of error, because you just told me your whole lab was messed up. Okay? You never want to say that. Okay? Fix it if you can. If you can't fix it, then your lab is a problem. Okay? There's something in the design that didn't work right. Okay? Everybody understand that? Okay. So that's going to be the expectation, okay, for how your labs will look when you hand them in. Okay? Now, again, I'll give you a template that has all of those sections on it. So when you get a template, okay, it'll start with problem, right? And it'll be blank. You'll have to restate it in the form of a question, okay? Because I'll give you an electronic version of the lab sheet, sometimes a paper copy, okay? So you'll have the problem on there. You restate it in the form of a question in your own words, okay? Then, okay, you'll have your design, and it'll just say manipulated variable blank, okay? responding variable, blank, controlled variables, and it'll just be blank. You got to fill it in, okay? So you write in there, the manipulated variable is this because, the responding variable is this because, okay? The controlled variables are these. Here's how this one would affect the experiment. Here's how this one would affect the experiment. Here's how this one would affect it, and how am I controlling it? All that gets in there on the explanation, okay? Then you have your hypothesis. Okay, so on the lab template that I give you, it'll just say hypothesis. Sometimes I'll have if ... and ... then, just to remind you that those words need to be in your hypothesis. You fill it in. Okay, then there'll usually be the procedure that I've written. On the first lab, that'll be blank because you'll have to write it. Okay, and then there'll be a place, it'll just say data/observations. That's where you'll put your chart. Sometimes I make the chart for you and you just have to fill it in. Okay, sometimes you have to build the chart. Okay, if you're making graphs, that's where the graphs will go, all of that. You're going to fill it all in, but it's always going to be in kind of that order or that format. Okay? Questions there? All right, now, evaluation on these labs. Okay, in fact, I'll just hand out the lab we're going to be doing on Thursday here. Okay, so if you look at the bottom of that page, there's the scoring rubrics, okay, as well as the back of the page has got the scoring rubrics, okay. Those are always going to be on the lab handout, okay. They won't be on your lab report template, okay. It'll just have this. It'll just have at the bottom my scoring area, which will be, design out of 5, hypothesis out of 5. Okay, the rubrics won't be on there, but you will always be able to see them because I always include an electronic version of the lab sheet in Google Classroom along with it. Okay, so your design is going to be out of 5 marks, and in there, okay, basically you're looking for, did you identify all the variables correctly? Okay, so do you have the manipulated, responding, and control variables right? Okay, and are your explanations of each one thorough and valid? Okay, if they are, then you're going to get 5 out of 5, okay? And the problem restated as a question, okay? Then you get 5 out of 5, all right? For your hypothesis, okay, is it clear? Is it relevant? Is it if, and then? Okay, does it say what you think is the solution or what you think is the relationship? Tell me how you're going to test it and what your predicted results are going to be. If all of that is included, okay, then you got a 5 out of 5 hypothesis. Remember, I'm not going to mark whether your hypothesis is right or wrong, okay? I'm going to mark, is it in the right format? Does it set out what you are going to do in this lab? All right? Lots of times we generate a hypothesis and we find out later that hypothesis is wrong. Okay? That's okay as long as we say that in the conclusion. All right, and then after that, okay, you'll see equipment and procedure. That one isn't always on there, but in this case, because you are designing the procedure, there's 5 marks for the quality of your procedural design. Okay? Most of the time on most labs, that mark isn't there, okay? Because I've done the procedure and all you have to do is follow it, okay? So in there, we're looking for, did you have a good list of materials? Was your design thorough? Okay, did you mention how you were going to control things? Did you mention amounts and observations you're going to make, all of that kind of stuff? How thorough were you on a scale of 1 to 5? Okay, and then you got your data and observations. It's out of 3 marks. Basically, are they all there? Okay, are they right? Okay, and basically that's it. So 3 marks for the quality of your data/observations. And then 5 marks for your analysis. Okay, in this case, the analysis for this question, okay, is simply identifying the unknown compounds as ionic or molecular and then their actual identities. That's 5 marks on this lab. Okay, so substance A ended up being sodium chloride, okay, or substance B ended up being water, or whatever it ended up, okay? So you're writing well, on your Google Docs version of this, okay, you're filling in that chart, okay? That's your 5 marks for this one. And then there's your conclusion, okay? Your conclusion is out of 4 marks, okay? Did you restate your hypothesis? Okay, you got to do that, okay? And then was your explanation for accepting or rejecting it valid based on what you did? Okay, then your evaluation out of 3 marks, so your 2 sources of error and ways to improve them, and then your overall report out of 5 marks, okay? If your report makes sense, it's in order, okay, it's not full of spelling mistakes, okay, things like that, then you're good, all right? If it sounds like my 6-year-old wrote it, okay, then that overall mark probably won't be so good. Right? Make sure that it sounds like, a 15 or 16-year-old high school science student wrote your report. Conversely, if it sounds like someone's PhD level thesis, okay, I'll know you didn't write it. Okay? So make sure it sounds like it was yours. Right? Everybody follow the evaluation there? Okay, so they'll all be evaluated according to those rubrics every time we do a lab. All right.